Hello guys, I'm back. In this video, I will talk to you about the relationship or the interface between the chemical process engineer and the electrical engineer. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Follow my profile and like this video to get hundreds of contents related to chemical process engineering and plant design. And the inspiration for this topic comes from my YouTube channel where I have this following request. Can you make a video about interface of chemical process with electrical? The person shares a list of load list in the question, and I would like to know some basics of the below loads, like what does it do, when does it operate, sequence of operation, which of the load operate during normal production, which of the load must run during non-production, and etc. And this is based on FPSO process. So here we have someone that has a list of load list with the motors for a process in FPSO, and he is interested knowing how to deal with this document, how to know what kind of load will operate, do not operate, what is the sequence, and etc. So to start with, let's review or let's remind how a process engineering project works. We have the product specification, we have the raw material, and between the product specification and the raw material, the chemical process engineer will define the equipment and process needed to achieve the requirements of the scope of the process or the scope of the process requirements. So it means that as a chemical process engineer, we'll define if I need rotating equipment or not. Do I need compressors to pressurize gas? Do I need pumps to pressurize liquids? Do I need to have vessel separators to split the vapor phase from condensate? Do I need to have heat exchangers, etc.? So what is the kind of control that I must have to achieve the product requirements? I will have pressure control, temperature control, flow control, and etc. So all of these questions will lead to the design of the process that the chemical process engineer is responsible to propose. So based on that, we'll have static equipments like vessels. We'll have rotating equipments that most often will be the source of power will be electricity, and we'll have instrumentation and controls, and they are fed with electricity also. But in the list load, basically we have a list of motors for the process. And the correct way to verify what is in operations, what is spare, what is supplied by the motor generator, and etc. is not going to the load list, in my point of view, because the load list is a consequence of what the chemical process engineer imagined, designed for the process. As a chemical process engineer, I will define if I need one pump running at 100% or if I will have two pumps running at 50% or one pump running at 100% and another standby. As the chemical process engineer, I will inform to the electrical engineer if I need what are the loads or what are the charges that must be kept in operations, although I lost the power source of my process. For instance, there are some key elements that I must have electricity to run, although my plant shut down. For instance, the control room, PLC, for instance, most often there is a generator, electrical generator to supply this kind of stuff to guarantee the safe condition or the safe shutdown of the process. In some process, we'll keep some equipment running, although the plant is shut down for some time. In the biomethane industry, when we are getting biogas from a landfill, for instance, it might desire to keep the pressure, the vacuum pressure at the landfill as constant as possible. So in some projects, I will have a motor generator to guarantee the operations of the blowers, biogas blowers, although I can lose the electricity from the concessionary, for instance. So the way that the equipment works, you will find in the process description of your process. There, you have the big picture, you have the details about what is running, what's not running, another document that can help you to understand what is the sequence of operations is the interlock description, the process description, the operating manual that will tell you or the operator or anyone interested on them how the plant works. And as I told you, the load list is a consequence of the process description defined by the chemical process engineer. So in this way, the interfaces that the chemical process engineer has with the electrical engineer. First one is to define the shaft power of all equipment, electrical equipment that is available in the process. If I have a compressor, a pump, I will do, as a chemical process engineer, the calculations of the shaft power and inform those information to the electrical engineer in order that they are able to size the best motor for the equipment if the motor is not supplied with the equipment. Another important interface between the chemical engineer and the electrical engineer is related to hazard area classification. As a chemical process engineer, we need to inform for the electrical engineer what or where is or where are the areas where I can have flammable gases, because that will lead to a special kind of design requirements for the electronic and electrical components. So the hazard area classification is not only important for the electrical engineer, but also for the automation or for the instrumentation engineer, because the instrumentation has electronic parts, electrical parts. So in this way, when we are doing a process for the first time, first the chemical process engineer will define the equipment. Some of the equipment will have electricity as the power source, and based on that, the electrical engineer will verify what are those equipments and get those loads and do the calculations for the motors of the project. And they will build a load list in order that this list can be used for the development of the process, for the maintenance, for the operations, and etc. So in this way, my point of view, if you want to understand about the process, go to the process description, to operating manual, or to the interlock description of your process, and not for the load list. You as a chemical process engineer eventually will use a load list to verify if, in a case of a revamp of your system, if I want to increase the capacity or change the process conditions of my rotating equipment, if the current motor, the existing motor, is available to handle that or not. Besides that, we don't deal too often, we don't deal with the load list developed by the electrical engineer. So guys, this is it. If you want to know more about chemical process engineering plant design, take a look in the next video that will appear to you right now. Bye bye.